Hello everyone, my name is Pattarapanyawong. I'm a master degree student in aquaculture at Faculty of Fishery, Kasetsart University. The title of my thesis is Genetic Parameter for Growth Rate in Thai Asian Sea Bass. It's under the supervision of Professor Swati Phumpuang and Professor Suriyan Hanjit. Today, I'm glad to present a literature review on a genetic parameter estimate for growth rate in fish. My review is based on two papers. The first one is genetic parameter estimate for growth performance in at harvest in Japanese powder by Lee et al. 2018. It's published in Journal Aquaculture. And the second paper is heritability of growth rate in the Asian sea bass by Ye et al. 2017, published in Journal Aquaculture and Fishery. The main goal of selective breeding program in aquaculture is to enhance growth performance and increase disease resistance. A number of studies demonstrate that improvement of both growth and disease resistant traits lead to more efficient production and higher benefits. But in my presentation, I will focus on selection to increase growth. Fish growth in specific age can be measured using body weight, terrain, standard length, condition factor, average daily weight gain, and specific growth rate. At initial, important step of selective breeding is to estimate genetic parameters, including heritability, um, phenotypic, and genetic correlation. Heritability is the most important parameter for planning breeding program. Heritability measures a proportion of phenotypic variance that is caused by the additive genetic variance. The value of heritability can be ranged from 0 to 1, but in aquaculture species, the estimated heritability for growth rate ranges from 0 to 0.83. Genetic correlation measure whether two quantitative traits were controlled by the same gene. The parameter can be either positive or negative. If two traits are genetically correlated, selection for one trait will also cause genetic change in the other trait. For example, if growth and disease resistance are positive correlated, selection for increased growth will result in disease resistance as well. Uh, for this slide, show the mating design for Japanese flounder. The base population comprise fish from South Korea, Japan, and China. Briefly, the author used 117 observed and 192 of them from different year class to produce 186 full seed family by artificial insemination. The batchfish were tagged using passive integrated transponder, and offspring were tagged using visible implant elastomer tag at 120 to 150 day post-hatch and were placed in the same tank. The growth data were collected at hatching and at harvest, and the blowout period of each year catch shown in this table. Three statistical models were used to analyze growth data in Japanese flounder, and detail in each model shown in this slide. Next, I would like to talk about the nesting design for the agency bass paper. The author set up a base operation by collecting fish from Malaysia, Indonesia, Thailand, and Singapore. In F1, they collect the batch fish using microsatellite marker to avoid inbreeding. The F2 fish were produced by mass cut of 10 to 15 male and female. At 90-day pod hatch, the fish were tagged with pit tag and were laid in the same tank. To reconstruct the pedigree, uh, DNA were extracted from fin clip sample and genotype using 10 microsaccharide marker. The fish were measurement for growth rate at the tagging and at harvest. The author used statistical model and SVML software to analyze the data. This slide shows results for Japanese founder. Palatability estimated for growth rate vary depending on model and ranking from 0.12 to 0.39. For agency base, predictability for body weight and total length were larger for 270-day pod hat than for 90-day pod hat. In Japanese founder, the genetic correlation between body weight, total length, and energy were high and positive, ranging from 0.87 to 0.94. However, the genetic correlation between both condition factor and auto trait were low to moderate, ranking from 0.38 to 0.58. In the agency base, the correlation between body weight, total length, standard length, and condition factor rank from weak negative to weak positive. In Japanese founder, the author compared their heritability estimate with previous work by Louis et al. 2011 and found that the results were similar between the two studies. The author also discussed that the heritability estimated for growth rate in Japanese flounder was similar in other fatfish species and Atlantic salmon, being a low to moderate level. In the agency-based paper, the author found that their results were similar to the previous study by Domingo et al. 2013, and the heritability estimates were higher at 270-day pod hat than that for 90-day pod hat. In conclusion, the result from these two papers indicating that there was a substantial amount of genetic variance for growth rate. Selection will be successful to improve growth in both species. In agency, this data suggests that in fatfish species, total length which is an easily measurable trait and more favorable than selection on body weight and ADG. And in agency base, palatability for body weight at 270-day pod hat is then highest among all the estimated heritability, indicating that among all the traits considered, body weight at 270-day pod hat has the highest accuracy of selection. Genetic correlation between body weight and total length in both fish were highly and positive, more than 0.8, indicating that selection to increase body weight will result in increased body length as well. And finally, methodology in this paper can be used as guideline for experimental design in my research. End of my presentation. Thank you.